Seeing is not believing. Jeffrey Fuerst. Exploring light and vision. Look around. Is sunlight streaming through a window? Does a lamp shine nearby? Light is an important part of our world. Can you imagine life without it? There would be no color. There would be no daytime. Without light, no one could see anything. The theory of light has been debated for centuries. Some scientists believed that light was made up of waves. Others believed it was made up of particles. Over time, scientists discovered that light has both waves and particles. Scientists study light and vision through the branch of science called optics. You can see how light changes things if you shine a torch in a dark room. Rays of light will shoot out in straight lines from the torch. When the light strikes an opaque object, such as a person's face, some of that light reflects into your eyes. Your eyes then send a message to your brain. Your brain recognizes this particular set of reflected light rays as a friend's face. This is vision. Now switch off the torch. The friend's face will seem to disappear into the blackness. Turn on the light again, and the face will reappear. Without at least some light, it is impossible to see an object. You can change the look of a person's face by shining a torch on it in a dark room. Rays of sunlight shine through gaps in the trees. Light always travels in straight lines. Light, the eyes, and the brain all make vision possible. First, light enters the eye through the small opening in its center, called the pupil. Next, the lens focuses this light to form an image or picture of what you are looking at. When the image or picture forms on the retina at the back of the eye, the image is upside down. This upside-down image is sent to the brain along the optic nerve. The brain receives the image, turns it the right way up, and makes a picture in your mind. Different parts of the eye all work together with the brain to make seeing possible. The eyes and brain function as a team. Since the eyes are set apart from each other, each eye sends a slightly different image to the brain. The brain puts the two images together into one. This ability is called binocular vision. It helps us judge distances and depth. Your brain blends the images from each eye together. See for yourself. Trick of the eye. 1. Cover your right eye with your right hand. 2. Point to an object in the distance, using your left hand. Look at your finger and the object. 3. Continue to point at the object with your left hand. Uncover your right eye and cover your left eye with your right hand. Now look at your finger and the object with your right eye. What happens to the object? Tricks of light. When light hits an object, it can do many things. How light behaves affects what we see. Light can create dark shadows. It can bounce off an object and create a reflection. Light can also refract, or bend, when it moves from one material, such as air, into another material, such as water. Shadows. A shadow is a dark area from which light has been blocked. You can explore shadows with a torch in a darkened room by shining your torch at a wall. Put your hand in front of the torch's beam. A shadow will appear on the wall, because your hand is opaque. All that you will see of your hand is its outline. The hands blocking this light are making an animal shape. Can you guess what it is? Early morning sun position. Midday sun position. Late afternoon sun position. The size and direction of shadows changes during the day. The sun appears to travel across the sky from east to west every day. As the sun appears to move, the angle from which its light comes also moves. The shadow is always on the opposite side of the object from the light. The shadows are longest when the sun is lowest in the sky. See for yourself. Shadow play. 1. Place an object on a table. Shine a torch on it. 2. Look at where the shadow appears. Notice its size and shape. 3. Move the torch from left to right. Now move it close to the object, and then further away. When is the shadow longest? When is it shortest? Reflections. Light travels along a straight path until something stops it. If the object that stops the light waves is smooth and shiny, it reflects the waves. It bounces the light waves back, like a ball bouncing off a wall. Many flat, shiny surfaces reflect images, such as a pool of water at the beach. See for yourself, light on a flat mirror. 1. In a darkened room, shine a torch directly onto a mirror. Does the room brighten? If it does, it is because the light is reflected. 2. Now move the torch so it shines at an angle. Does the light reflect off the mirror? If it does, it reflects off the mirror in the opposite direction. Your reflection from a flat surface, such as a mirror, looks almost identical to you. It is the same size and shape, but it appears reversed left to right and front to back. The person you see seems to have turned around to face you. When you raise your right hand, your reflection appears to raise its left hand. When you look in a mirror, what is different about your reflection? Curved mirrors, which reflect light at different angles, show funny reflections. Reflections in amusement park mirrors look strange. Some images are stretched out, while others are squeezed and flattened. This happens because the mirrors are curved. These curved mirrors reflect light rays at many different angles, not evenly as a flat mirror does. A convex mirror curves outwards and always makes objects appear smaller. A concave mirror curves inwards. It makes objects near its surface appear larger and the right way up. However, distant objects appear smaller and upside down. Convex mirrors, like this side view mirror, make objects appear smaller. Convex and concave mirrors have many everyday uses. The side view mirror on a car is slightly convex. It helps the driver see a wide view of the road behind the car. A makeup mirror is slightly concave. It makes the image larger. Curved mirrors are also used in telescopes and other scientific equipment. See for yourself, convex or concave? 1. Hold the back of a metal spoon in front of your face. The spoon curves outwards like a convex mirror. What does your image look like? 2. Turn the spoon around. The front of the spoon curves inwards at the middle, like a concave mirror. Again, hold the spoon in front of your face. How does your image look different? Rainbows. Often you can see rainbows arch across the sky after it has been raining. When sunlight, which is white light, passes through the tiny droplets in the air, it is broken up into light rays of many different colors. These refracted rays of light spread out into rainbow bands of color. The colors of the rainbow make up the visible spectrum.